These Hampshire maths teachers have come together to discuss new projects they've been trying out in their schools to motivate their GCSE students.
Loads of things on it. We've got things
to look at the risks.
The session's been organised by Alison Clark-Wilson from the Maths Centre at University College Chichester and Maths Inspector and Advisor for Hampshire, Ron Taylor. Maths teacher Andy Grice describes the work he's been doing with his Year 10s at their school in Gosport.
And Andy?
We were doing trigonometry at the time, so what I felt I wanted to do was actually get out of the classroom. I wanted them to be out of the classroom, out of the normal environment. I didn't want to use any books. I wanted to do something very different. So what I want you to do in groups, okay, I've got a couple of pictures there of places around our Broome Park campus. What I want you to do for the first 3 minutes is think of the 4 highest points that you think are around the school, and I want you to estimate the height. Okay, so we've got 3 minutes. When I presented them with what we were going to do in the lesson, I think they kind of went through the change curve really. When anyone's presented with change, they kind of go through this anxiety. They start to worry. They don't know what's going to happen. So we've got 3 minutes now. So think about the 4 highest points around the school. When we talked through it, there was kind of this realisation, and then it kind of goes into acceptance and kind of more excitement really, because they're not used to doing something different.
That'd be 18 though. That's
18 metres.
And then you've got the roof as well. And you've got we've got the distances between the floors, and we've got the roof to add on to that.
2 or 3. 15 metres.
It kind of came down to, okay, they were working in a systematic approach. They were also about discussing things with partners because they were working in groups, and also they were doing some estimation of answers as well. 3, 2, 1. Okay, pencils down. What I want you to now do is just add the 4 buildings up for me and put the total in the bottom. There is an envelope on your table. I want you to fold your piece of paper up and put it into the envelope. And I want you to seal that envelope because we're going to look at that right at the end of the lesson. Your challenge today, the first thing is that you're going to collect data outside to enable us to find the height of those 4 buildings. We're going to see who is the closest to their estimation. So, for example, if this is one of you outside and we have a building here, what information do I need, thinking about the resources that you've got, to try and find the height of that building? What?
Length from you to the actual building.
We want to find the length from here to the building. We know there's a right angle. So can we form a triangle so that we get trigonometry? Yes, we can. But we need another bit of information. We've only got one distance. If we measure that distance, we can measure that with our meter tape. And we know that this is 90 degrees. What else do I need to try and find the height of that building?
The angle from the distance to the person's eye line that they're looking up to.
Brilliant, excellent. So I need to know that angle there, and I represent it by our angle theta. And this is where we're going to look at some of this equipment before we go. These are called clinometers, okay, and we have a variety. This is where you're going to have your choice, because what I'm going to do is you're going to choose your piece of equipment. So I'm going to choose this table. Which piece of instrument would you like? Yep. Okay, next table. So Philip's table, come up and choose. Okay, Wyatt's table and Jason's table. Those. What I want you to do within your teams is you're each going to have a role or a role of responsibility. You are going to elect between yourselves a team leader. You're going to have somebody who's going to be a recorder. You're going to have somebody who's going to be responsible, so I've put this as measurer 1, who will take responsibility for measuring the distance. And obviously they're going to have to work with someone to measure that distance. And secondly, you're going to have somebody taking responsible for the clinometers. So somebody to measure the angle.
Right, when I'm measuring this, I'll hold it and you measure how long it is, and then when you're doing that, I'll read the angle. Okay?
So just get used to the equipment. So what I'm trying to do is limit that potential off-task working by actually having team roles and what they needed to perform. So I am going to give you 20 minutes to get round your 4 sites and take all the details. So you've got to work fairly quickly and swiftly. Okay, you need to go to your 4 sites. What's the element of control like? You know, they're going to be out of sight, but I felt that I would take the risk that if I gave them a time period that they had to do it, then they'd be focused. They'd have 5 minutes essentially for each object. You've got to have a right angle triangle, so the top of the building needs to be directly below to where you're measuring to. So you're going to have to do some estimation, are you not? Okay, remember, if you're measuring distance, it needs to be taught the tape. 9 metres. And now what do you need to do? What's your third measurement you need to know?
Aim the thing at the... There we go.
29.2-ish.
Okay, you've got 15 minutes, I think, left. So you need to go to your next site.
It's like...
We've got to measure it right to the building, remember?
No, because we'll do it from up there.
Oh, right, okay.
So which point...
22.10.
Why have you not measured it right to the...
Because we're going to measure that bit up there.
So the...
Because obviously it'll be about a metre out.
Keep moving.
About 24.
So what are you doing?
Where's the highest?
It's
Like behind the roof.
30 degrees.
We need to be in the same same place as where you took the angle.
It's like 64.
7
metres.
4, 6.
Okay.
7 metres.
Right, let me wind.
7.6.
64.
I wanted to get them excited, but also I wanted to involve an element of competition as well, to kind of excite probably the boys of my group. I felt that competition would work well.
Let's show it back a bit.
To the green.
2015.
My personal belief is that if you structured the task correctly and you've given specific structure around it, such as time, then I think you've got a potential to succeed rather than a potential to fail. I think it was an exercise that enriched their trigonometry, and I'd put that beyond maybe a little bit of off-task working maybe by an odd group. So we're going to label this the hypotenuse. I'm going to call it HYP for short, okay? What else do I label then, Chelsea?
The 40-metre length,
So this distance along here,
is the adjacent.
so it's the adjacent, okay? So I'm going to label it ADJ, okay?
And
the remaining one is called?
the opposite.
The opposite. Okay, so we've labelled our diagram to start with. What's the second thing we do?
Work out which of the trigonometry ratios we have to use.
Okay, so name the trigonometry ratios that we've got then. What are the three trig ratios?
Sine,
Okay, so we've got sine.
cosine, and tangent.
Okay, and which lengths do we have?
We have the hypotenuse and we have the opposite and the adjacent.
Okay, do we have the opposite?
No. We have the opposite of the opposite angle.
Okay.
We have the angle.
We've got the angle, yes.
Yeah.
We want to try and find the...
Opposite.
We want to try and find the opposite, so we need that one. But what have we got?
Adjacent.
We've got the adjacent. So which trigonometry ratio will we use? Which got the opposite and the adjacent in?
Tan.
Tan. Yeah, so we're going to use tan. Okay, we've done some practice using tan. So what I want you to do now is with your 4 buildings, I want you to work out the height of those buildings. Okay?
You included the green roof?
Yeah. And then opposite over 22.1 metres. Multiply tan 20 by 14.8.
14.8 equals 5.38.
That's the Jam Studio. So tan
19.5.
19.5. Okay.
Tan 21 equals 0.3 times 19.5 equals 7.5.
I think we should both do it.
7.5 metres.
Then what they did was they took out their estimated values and worked out what the difference was. And the idea was that whichever group was closest to their estimated were actually the winners. So we're just going to go through the groups to see who the winner is. So we're going to start off with Natasha and Laura's group. What's your difference between your estimated and your actual?
39.78 metres.
So we've got 39.78 metres difference. Okay, Jess's and Sophie's group.
Our difference was 3.05 metres.
3.05 metres. So that is taking the lead. Okay, Was and Stacey.
51 centimetres.
51 centimetres. So we have 51 centimetres that is taking the lead. And also this group here?
4.7 metres.
4.7 metres.
4.7 centimetres.
Obviously, this group here wins with 51 centimetres. These are, however, provisional results, because what we will do next lesson is that we will check and compare all our heights for the same buildings, just to make sure that you've got the accuracy correct.
To what extent do they understand the margins of error within the measurements they've made and the results they've got?
What I was trying to do was focus more on the trigonometry, so I wanted kind of the full picture, and perhaps what I could have done is extended it over 2 lessons really. So we could have taken the data, they could have worked it out, then the next lesson we could have had that discussion about accuracy, we could have had the discussion about about any differences that people had and what the measurements were.
We're very concerned about being able to do things really accurately, that we don't consider the estimation side of it enough, and that are we near enough to be okay, and we don't necessarily give them those skills if they're very bright.
I think when I teach some of my bottom groups, we get the metre rule out, we physically measure things, we work out whether it's this width and they've got an approximate value. And I think when we teach top groups, they can work out the concept in mid-air, but practically and physically, they couldn't. One of the groups couldn't even work out what a metre looked like.
We enjoyed doing it, but at first we sort of misinterpreted the idea of a metre.
We thought it was like that big, not like that big.
I enjoyed it, it was something different, and again they felt it kind of clarified their learning.
We enjoyed it quite a lot more than lessons because it helps if you can like visualise things instead of just having to look at a textbook. And it's a lot more enjoyable because we actually got out.
Especially when it's competition as well, you've got more of an incentive to work.
It was good to see things a bit more visually.
It was interesting, so it's a lot better to be able to be out doing it rather than just doing it from a book.
Like we always have to like just sit here like writing, it like gets boring and like don't understand it as much.
It was a good way of learning.
64. No, definitely that way, in line with me.
I wanted them, instead of just looking at a question, thinking what they needed to do and then doing it, I wanted them to be involved in that process so they could visualise. It comes down to visualisation really, in terms of how they remembered on how to do it, what they needed, and therefore then the process of trigonometry.